In mathematics, we learn about real numbers. And real numbers consist of integers like negative numbers and positive numbers, including 0. Also, you would have learned from rational numbers, which is like decimal fractions, and irrational numbers, including special numbers like pi or the square root of any number, which is irrational. So you would also have learned about non-real numbers. And non-real numbers would be numbers, for instance, like negative -4. So this does not have a real solution. In mathematics, however, mathematicians have identified this number as a very important number to solve. So they said, imagine there is a number called, or imaginary number, and we depict it with a I, which is the square root of -1. So if you look at this imaginary number, if we get the square of I, it would be the square of the square root of -1, which is just -1. So this is a very important number, and they identified this as something that is really needed in solving equations. So if we know that with the root laws that the square root of -4 is -1 multiplied by 4, we can also write that as the multiple of multiplication of square root of -1 multiplied by the square root of 4. And we know with this I that this is this, so the square root of I is the square root of -1, and the square root of 4 is 2. So let's say square root of 2 multiplied by I. So we can see with this that we can write that the square root of -4 is actually equal to 2i. So we can get a solution to this irrational or non-real number, the square root of -4. So this is called an imaginary number. Okay, so together the real numbers with imaginary numbers forms a new type of number that we call complex numbers. So a complex number is always a number that contains a real number, like for instance, let's say -3, and a multiple of the imaginary numbers, say +2i. So this is an example of a complex number consisting of a real number and a imaginary number. So we will be doing some different types of solutions with imaginary numbers. But let's just start with the basics. So we know that I is the square root of -1. We know that I squared is -1. I to the power of 3 would be I squared multiplied by I. And we know I squared is -1, so it will be minus I. I to the power of 4 would be I squared multiplied by I squared. And we know that's -1 times -1, and that's equal to 1. So this is very important to see. So if we look at the square root of 5, we know that that is actually I to the power of 4 multiplied by I. And we know that I to the power of 4 is 1, so this would just be I. So we can see multiples of 4 of I is always equal to 1. So we'll see I to the power of 4 would be equal to I to the power of 8, would be equal to I to the power of 12, which is all equal to 1. So if we need to solve an equation or a problem that says I to the power of 63, we know that the multiple of 4, which in this case would be 60, so multiple of 4, the multiples of 4 of I will always be equal to 1. So you can see I to the power of 4 is always equal to 1. So that would be equal to 1, and the remainder, I to the power of 3, would be the solution. So it will just be I to the power of 3, and we know I to the power of 3 is just minus I. So now we can solve any multiple or any power of I. So for instance, I to the power of 1003, or let's make it 1002. And what you'll do is you'll say, okay, let's divide 1002 by 4, and that would be equal to 240, and the remainder would be 2. So the solution to this will actually just be I to the power of 2, because multiples of 4 would always be equal to 1, and this would be just minus 1. And this is how you can solve any multiple of an imaginary number.